Okay, so in this video we are looking at another application of ratios, which is scale drawings. Now, any scale or model is used to represent an actual thing. So if we take, for example, the model of a building, that's going to be a smaller scaled down measurement compared to the actual thing. Now, we write these scales and represent them by using the ratios we are given. So if we look at an example, let's say I have a scale of 1 to 10,000. That means that for every 1 unit measurement I make on my model, the actual thing is going to be 10,000 times that. And we can define the actual scale as the length on the drawing or model, whatever it is you're doing, over the real length. So if we look at actually applying this concept, let's say we have this particular scale and we want to think about what the length of the scale drawing would be to represent a distance of 85 meters on actual land. So this 85 meters is our real length. And using this particular thing we came up with here, if our scale is 1 to 10,000, that means that our scale is going to be equal to 1 over 10,000, because we are just taking the ratio and representing it as a fraction. So what we have here, we're trying to find the length on the drawing. So that means our scale for this particular drawing, we have a real distance of 85 and a length that we're trying to find. So that means we're going to be using this particular fraction on the right hand side. So we're going to write the length of the drawing, because that's what we're trying to find. That thing over 85 meters is going to be equal to the scale as a fraction that we found, 1 over 10,000. So this just becomes an equation that we can solve. The length of drawing divided by 85 meters equals to 1 over 10,000. So like with any equation, we can times, since it's dividing on the left-hand side, we can multiply to get rid of it. So the length of the drawing is going to be 1 on 10,000 times by 85. And that's going to give me 0.0085 meters, or I can write this as 8.5 millimeters. Okay, so looking at another extension of this idea, we're going to try to find, in the previous example we looked at finding the drawing length when given the real length. Now we are going to try to find the real length given the drawing. So first of all, I have, let's say for example we have a map distance of 28 millimeters, and we have a scale of 1 to 500. Now, as we said before, our scale means that for every 1 unit on our drawing, the actual thing is going to be 500 times that. Because for every 1 measurement unit on our drawing, there's 500 measurement units on the actual thing. This is where ratios are kind of unitless in a way, or they can adapt to the different units we include. Because the first definition we looked at for ratios is that they compare the same quantity. So we're going to have the same unit lengths. So that means that our actual scale, our actual real length is going to be 500 times whatever our measurement is. So we can take 28 millimeters and just times this by 500, because for every one on our drawing or on our map here, for every 1 millimeter on our map, we're going to get 500 millimeters on our real length. So that's going to give us 14,000 millimeters or 14 meters. Now, we can also do this using the fraction we set up before, like this, and it'll give us the exact same answer. So for example, let's call this method 2. We can redraw this as, well, we can rewrite this, sorry, as the length on drawing over the real length. So 28 millimeters over the real length equals to 1 over 500. Okay, now I can just rearrange this equation. I can multiply the real length across to the other side. So that gives me 28 millimeters equals to the real length over 500. And now I can just multiply the 500 to both sides. And that gives me the exact same thing I had up here. I'm going to get my 28 millimeters times 500 equaling to the real length. And that's going to give us the exact same answer. Now let's do one more example on a different concept. This is going to be finding the scale on a drawing when given two lengths. So a length of a drawing and a real length. So for example 3, let's say that I have the length on the drawing or model equaling to 32 centimeters, and the real length being 1,600 meters. Okay, so the big kind of problem here is that we defined before ratios as comparing the same quantity. So we need these units here to be exactly the same. So what I'm going to do, I'm going to convert my 1,600 meters into centimeters. And I'm going to do that by remembering that there are 100 centimeters in every meter. So I can convert from meters to centimeters by multiplying this length by 100. Now that's going to give me 160,000 centimeters. I've made this conversion. So now that these units are the same, I can just write it as a ratio. So what I'm going to do is I'm going to use what we defined before, which is that the scale is going to be 32 centimeters over 160,000 centimeters. And these units now end up cancelling out because this is just a ratio now. Remember, ratios are without units. So this gives me 1 over 5,000 in the simplest form, or I can actually write it as a ratio 1 to 5,000. Now that brings us to the end of the video and the series. Thank you so much for watching, and I'll see you next time.